question 1, it says write 9/10 as a decimal, so that's 9/10. And the easiest way to think about how to change a fraction to a decimal is to think of the vernaculum, the line that separates them, as the divide sign. If you notice, the divide sign always looks like that because it is in fact a fraction. So this is 9 divided by 10, which we should know gives us 0.9. For question 2, it says write 0.3 as a percentage. To change from a decimal to a percentage, we just need to multiply by 100. So 0.3 times 100. If you imagine what's happening there, the numbers are moving 2 to the right, so it's almost like the decimal point moves there. That gives us 30. So 0.3 is 30%. And for question 3, it says write the number 2538 correct to the nearest hundred. So that's 2,538. So we need to remember our units, our tens, and our hundreds, and that will be our thousands. Okay, so to the nearest hundred, we're deciding, does this stay a 5 or does it become a 6? The number next to it is a 3, so that tells us we round it down. Okay, that doesn't mean the 5 goes down, it means it stays the same, so that will be 2,500 correct to the nearest hundred. Okay, question 4, it says here are the first 4 terms of a sequence. It goes 2, then 9, then 16, then 23. We need to write down the next term in the sequence. Okay, to work this out, you've got to see what's actually happening in this pattern. How is this to what's happening here? It's increasing. How much is this increasing by? Well, to go from 2 to 9, we need to add 7. And from 9 to 16, we also need to add 7. And then from 16 to 23, we also add 7. So you can imagine, to work out the next term, we just need to add 7. 23 plus 7 gives us 30. Okay. Part B, it says explain how you got your answer. We know that the pattern is increasing by 5 every time. Sorry, by 7. Increasing by 7. Okay, now to work out the 10th term, you've got a choice here. You can either carry on the pattern and keep working it out until you get to the 10th term, or if you have a stronger understanding of how to work out the nth term, that's a formula for any term in this sequence. In this case, it's going up by 7 every time, so that tells us it will be the 7 times table, or 7 times whatever your term number is. So for example, if n is 1, that will be the second, that will be the third, that will be the 4th term. And if we work out what 7n is, 7 times 1 is 7, 7 times 2 is 14, 7 times 3, 21, 7 times 4 is 28. Okay, so it can't just be 7n, because if it was just 7n, these would be the terms in the sequence. So what's happening to go from here to this number? You need to subtract 5, don't you? And then from here, you also see it's subtracting 5 every time. 28 take away 5 gives us the 23. So that means our nth term pattern will be 7n minus 5. Another way to think about this is, what would the term 0 be? So if I was looking for the term before this one, if you start at 2 and you take 7 away, you end up at minus 5. So it will be 7n minus 5. So if that's any term, to work out the 10th term, you substitute 10 for n there. So it'll be 7 times 10 take away 5, which is 70 take away 5, which gives us 65. And that will be the 10th term in the sequence. digits, 7, 3, 4 and 9. It says use 3 of these digits to write down the largest possible 3-digit number. Okay, so if we've got a 3-digit number, that means it's going to involve 3 digits, okay, where one's the units, one's the tens, and one's the hundreds. And if I'm using these ones to make it the largest possible, it needs to go in order from inside, from the largest, so it would go 9, and then the next largest would be 7, and the next largest would be 4. So in this case, 974 is the largest 3-digit number that we can make from here. Now, similarly, it says here are 4 different digits, 8216. It says put one of the digits in each box to give the smallest possible answer. So smallest possible answer to the sum. And you must use each digit only once. So this time we've got 2-digit numbers, so we're going to have units and tens, and then units and tens. Now, because we're trying to make it the smallest possible, this time the first digit needs to be as small as possible. So I'm going to put the 1 there and the 2 there. If you switch those around, it makes absolutely no difference. And then the next ones, the smallest numbers that you can think of will be 6 and 8, and that involves all 4 of the digits. And if you keep them in order of size going from smallest to largest, okay, it doesn't matter which way round they're swapped round. So you could have, for example, you could have the answer 18 and 26, which would make no difference to the answer. Okay, as long as you keep it so that the tens are the small digits and the units are the larger digits, you'll get the smallest possible answer to the sum. Okay, question 6, it says write down all the factors of 30. Okay, remember, a factor of a number is a number that divides exactly into this number here. So what numbers divide exactly into 30? Okay, a useful way to remember how to find all the factors is to do what's called a factor bug. So if I start with 30 in the middle there, that is 1 times 30. Okay, does 2 go into 30? Because it's an even number, it goes exactly 2 times what gives us 30? That would be 15. Does 3 go into 30? It does. 3 times 10. Does 4 go into 30? Now 4 doesn't go into 30 exactly, because if you divide 30 by 4, that's the same as 15 divided by 2, which is 7.5. So therefore 4 is not a factor of 30. Does 5 go into it then? 5 does go into 30 6 times, because it's 5 times 6. And now the next number, does 6 go into there? We've already repeated ourselves, so that means we've found all the possible factors. So in this case it's 1, 2, 3, 5, 6, 10, 15 and 30. They are all the factors of 30. Okay, question 7. It says David has twice as many cousins as Becky, and Becky has twice as many cousins as Nishat. Nishat has 6 cousins. How many cousins does David have? So there's David, there's Becky, and there's Nishat. And Nishat has 6 cousins. And it tells us in the question that Becky has twice as many cousins as Nishat. So 2 times 6, that means Becky has 12 cousins. And David has twice as many cousins as Becky. So times that by 2 gives us 24. So how many cousins does David have? He has 24. Okay, question 8a, it says find the value of, and that symbol there means the square root of 1.44 times 3.61. Okay, I'm going to do that straight onto the calculator. So pressing the fraction button, we get 1.44 times 3.61. If I press the equal button, it gives me the answer 2.28. Okay, similarly for this one, it says find the value of 3.54 minus 0.96 squared minus 4.096. You can, if you want to, break this down into small steps, but if you use the Casio calculator, I'd advise you to do it just all in one step, as long as you keep everything exactly as it's written, especially the brackets there. There's 3.54 minus 0.96, close the bracket and the squared button's there, minus 4.096, and that gives us the answer 2.5604. So this question is just a test of your ability to use your calculator efficiently. Okay, question 9, it says this is part of a bus timetable between Bury and Manchester. So here we can see the part of the timetable. For part A, it says how many minutes should the 8:25 bus take to go from Bury to Manchester? So starting from here, how long does it take? Well, it starts at 8:25 and it gets to Manchester at 09:05. Now, a common mistake that people make here is thinking if I just do 9:05 minus 8:25, that will give me the correct answer, but that won't work because that's if it's base 100. In this case, we're looking at times, and that's base 60, so we need to realize that from 8:25 to go to 9 o'clock, you're not getting to 8 hours and 100 minutes, it's 8 hours and 60 minutes. So if it helps, break it down into little chunks. So starting at 8:25, if we add 5 minutes, that gets us to 8:30, and if we add 30 minutes from there, that takes us to 9 o'clock, and then to 9:05, which is what we're trying to get to, that's an extra 5 minutes. So all in all, it takes 5 plus 5, which is 10, plus 30, it takes us 40 minutes for the 8:25 bus to go from Bury to Manchester. Okay, Daniel goes from Whitefield to Manchester by bus. He takes 17 minutes to get from his house to the bus stop in Whitefield. He takes 15 minutes to get from the bus stop in Manchester to work. Daniel has to get to work by 10 a.m. and he leaves his house at 8:45. Does he get to work by 10 a.m.? Okay, so starting from the beginning, okay, if he leaves at 8:45 and it takes him 17 minutes to get from his house to the bus stop in Whitefield, okay, if I add 17 minutes there, okay, we can break that up if you like, 8:45, so let's do plus 10 plus 7 if it helps, that'll get us to 8:55, and then add 7 minutes to there will get us to 9:02. So that's the time that he gets to the Whitefield station. So what's the first? He can't take the 8:34 because he's too late for that. The earliest train he can take is the 09:04, which means he gets to Manchester. So if he takes the 9:04, he gets to Manchester at 9:35. And it says he takes 15 minutes from there to get from the bus stop in Manchester to work. So if I add 15 minutes along there, 9:35 plus the 5 gives us 9:40, plus the 10 gives us 9:50. So does Daniel get to work by 10 a.m? Yes. Daniel arrives at 9:09:50. Should write AM. Should always write AM or PM, just to make sure you get the marks there. £11.20 per hour. And it says Bronwyn worked for a total of 20 hours last week, and she worked 8 of these 20 hours at the weekend. So she's worked 20 hours, and there's 8 hours at the weekend. How many hours has she worked from Monday to Friday? 20 minus the 8 gives us 12 hours. So she's done 12 hours from Monday to Friday. That means to work out her pay, we would need to work out Monday to Friday times 12, so that's £8.40 times 12, and £11.20 times 8. And let's see what we get from there. Let's take our calculator out. In this case, it's £8.40 times 12, and that gives us 100.8. Then 11.20 times 8 gives us 89.6. And if we add those together, I'll do it with a calculator just to show, plus 100.8, notice I use the answer button there. That gives us a grand total of 190.4. So Bronwyn was paid £190.40. Don't forget to put the extra decimal place there to show that it's in money. And that therefore shows that Bronwyn was paid less than £200. Okay, question 11. It says last year the cost of a season ticket for a football club was £560, and this year the cost of a season ticket for the club has been increased to £600. So write down the increase in the cost of a season ticket as a fraction of last year's cost. So to work this out, first of all we need to work out what the actual increase is. In this case, it's gone from 560 to 600, so what's the difference between them? That would be exactly 40. Okay, so that's the actual increase. And then the fraction as an increase compared to last year's cost is 40 out of 560, which is the same as 4 over 56, which is the same as 2 over 28, which is the same as 1 over 14. Any one of these questions will answer, will be good enough for the answer for the full marks. It doesn't say leave it in its simplest form, but it's always a good habit to get into, to be able to simplify your fractions. Okay, question 12. The diagram shows a scale drawing of a tennis court, and the scale of the drawing is 1 to 200. We need to work out the perimeter of the real tennis court and give our answers in meters. Okay, so first of all you need to get a ruler out and measure these lengths. This length here you should measure as 11.5 centimeters, and the length upwards should be around 5.8 centimeters. Okay, and once you know that, to work out the perimeter you would need to add all 4 lengths together. But in actuality, what you need to do here is work out, because the scale is 1 to 200, that means 1 centimeter here is 200 centimeters in real life. So if I times that by 200 and that by 200, let's see what lengths we get. So 11.5 times 200 gives us 2,300. same, so 2,300 and 1,160. So if we add all those together, 2,300 twice, and then 1,160 twice. I'd advise in the calculator papers to always use your calculator rather than trying to do this manually, simply because it's a calculator paper. You don't want to make those mistakes. So start with 2,300 plus 2,300 plus 1,160. 1,160. That gives us 6,920. And what's my units here? Well, the original measurement that I did was in centimeters. So that means this is 6,920 centimeters. So to change that to meters, how many centimeters are there in 1 meter? There's 100, so we need to divide this by 100. That gives us 69.20 or 69.2 meters, and that is our Okay, question 13, it says here are 6 straight line graphs. You've got graph A, B, C, D, E, F. And it says match each equation in the table to the correct graph and write down the letter of the graph in the table. Okay, so let's start with this first one. It says y equals 2. Now, we've got to remember that whenever you're looking at coordinates on a graph, they're always in this format, where the first number tells you how far across x you go, so left and right, and then the second number tells you your y distance. So in this case, if there's no x value and it's just telling us that the coordinates, the y is always 2, that would be this graph here, because no matter where you go on this graph, for example, that point there is 0, 2. This point here would be 2 across and 2 up. So it's the one where all the y values are always 2. So that would be graph D. Now for y equals x, if you imagine what that's saying there, you've got the coordinates 1, 1, because y and x are the same, 2, 2, 3, 3, etc. And if we look at these graphs here, you can see that here, that's 2, 2. So if we were halfway across, that would be 1, 1. And it would be 0, 0. So this graph F is the graph of y equals x. And then finally x plus y equals 2. What this tells us is if you get the 2 coordinates, they will always add up to 2. So if my x was 0, my y would be 2 in this case. 0 plus 2 equals 2. If my x was 2, my y would be 0. So which graph matches this one? In this case here, if you look, you've got 0, 2 there, and you've got 2, 0 there. So that graph A is the graph of x plus y equals 2. Before I get started, I'm going to do a draft one thing missing from my diagram. How would I know if I was reading this diagram what this number is? This 7.5 or 75? So you need to put a key in just to make sure you understand this. So for example, 694 equals 64. That is it says one of these students is going to be chosen as a pass mark in the French test is 71. So anything above this point here is passed, so that'll be anything further than that. And Omar writes, the probability that the student failed the French test is 1 in 4. Well, what's the probability out of all these 20 students? That's something to remember. Out of 20 students, how many did fail? Well, 71 would pass